Hello everybody, get ready to do lesson 8.6 part 2, pre-algebra, writing linear equations. And in this lesson, there's 25 points here of classwork skill sheet.
And we have 0 points for notebook taking.
And then there's 26 points here of notebook taking, so pull out your notebook. And let's see here, example 3, I think, writing equations of parallel or perpendicular lines. Write an equation of the line that is parallel to line y equals 4x minus 8 and passes through the point 0, 2. So how do we write an equation of a line that is parallel? The slope of the given line, which is this is given, is 4. So the slope of the parallel line is also 4. The parallel line passes through 0, 2, which is a y-intercept. When x equals 0, y equals 2. So its y-intercept is 2. We know that much. So the equation of the line that is parallel to this line is 4x plus y equals 4x plus 2. Because the slope of the given line is negative 5. This is a different situation here. We're talking about a line that has a slope of negative 5. The slope of a perpendicular line is the negative reciprocal of the existing line. So this is negative 5. The negative reciprocal of negative 5 would be 1 over 5. The perpendicular line passes through 0, negative 9, so its y-intercept is negative 9. The equation of the line is y equals, and this would be the perpendicular, y equals 1/5 x minus 9 would be the equation of the perpendicular line to this line here. Now we go into our guided practice. Write an equation of a line that is parallel to this line here, and it goes through this point as well. Parallel line goes through this point and is parallel to that. So let's see what that is. And then down here, students, you have to write an equation of a line that is perpendicular to this line, and which goes through that point there. Okay, so for a guided, here would be your solution for the guided. The slope of the given is negative 8, so the slope of the parallel is also negative 8. The y-intercept is negative 2. So the slope, the equation of the parallel line would be negative 8x minus 2. And then down here, this is you, student. Get on that. On to example 4, write an equation from the table of bamboo growth and then make a scatter plot. So here's our table of growth. Here is the scatter plot that represents this table here. And our time is our x, our domain, and our range is our height for that. So first thing to do to write an equation of that line is to find a slope. And we pick out 2 spots, any 2 spots. And we get 2 here for m, which is our slope. And then find y-intercept of b. The line intersects the y-axis at 0, 6. So b equals 6. If you look at the table, you'll see 0, 6 is a ordered pair. So that is your y-intercept. And then write the equation y equals mx plus b, and that is this. Here we just plug in from what we've done up here. 2 is m, and then 6 is b, and this is our equation of that line. Now we go into another guided practice here. Show that the table represents a linear function, then write an equation for the function. So to show that it represents a linear, it is a function. For each input, there is only one output, so it does have that functionality to it. And then do the same thing down here. Then write an equation. So to write an equation of this table here, we have to find slope first. So we pick 2 random numbers here, 7, 2, 7 rather, and then 0, 1. This is a y-intercept here. 0, 1 is. Anyway, we figure slope's 3. We plug that in for m. So we get y equals 3x plus 1 for this line right here. Down here, you're on your own. Okay, onward to slide number 6 in your notebook entry here. Best fitting lines in example 4. The points in the scatter plot lie exactly on a line. Often, however, there is no single line that passes through all the points in a data set. In such cases, you can find the best fitting line, which is the line that lies as close as possible to the data point. So, in example, the following example uses a graphical method to approximate the equation of a best fitting line. In the activity on page 425, you use a graphing calculator to find a better approximation. So into this example here, 5, the table shows the number of female physicians in the U.S. for 92 through 99. And then these are the years since 92. And then these are the female physicians, the number. And then approximate the equation of the best fitting line for the data. So a solution to be found would be to make a scatter plot of the data first. So plot this, plot, or a grid, or you can sketch it here if you want. On your worksheet, here is a sketch here, or a grid of the data. Next, draw the line that appears to best fit the data points. There should be about the same number of points above the line as below it, so the line does not have to pass through any of the data points. So the line needs to go through the array here of plots. Okay, so we got a line, now what? Now we need to figure out slope. So we pick 2 spots on our plot, which is 0, 108, the y-intercept, and then 7, 177. And then we figure our slope. It is a line, so any 2 points figured into our slope formula will give us a correct slope, which is 9.86. So there's our m. And then our b is 108. That's our y-intercept. So now we can write an equation. Approximate equation of the best fitting line would be y equals 9.86 plus 108. And finally, predict the number of female physicians in 2005. So that's 13 years after 92. So we plug that in for x. And we get 236 for our number of female physicians in 1992 using that data. So in 2005, there will be 236,000 female physicians in the United States, according to that model there. Who knows? Okay, so into our guided practice, we have a marathon issued here, Boston Marathon every 10th year from 1900 to 2000, men's winning times. In the table, X represents the number of years since 1900, and Y represents the corresponding winning time to the nearest minute. So you can see it was 160 here in 1900. And it's dropped down to 130 minutes. Make a scatter plot of the data. Draw a line that appears to be best fit the data points. That's A, and then B, write an equation. So for the line. So the scatter plot for this data would look something like this. So you see your times are falling here. This would be a general trend line here for the data. And then we are going to find slope here. We choose our y-intercept, and then we choose let's see, what, 90 and 130, so that'd be like here, and then 130 be here. We use that to figure our slope, which is negative 1/3, and then we stick that in for M. So the line intersects the y-axis at 160. That is our B right there. So negative 1/3 x plus 160 would be a an acceptable equation for this line here. Then we have a vocab. We'll now define in your own words best fitting line.
Hello,
And that is lesson 8.6, part 2. If you need worksheets or quizzes or tests,
is available here.
email me here. Thank you very much.
Email address as well as everything.